video, we'll be talking about software. Software are the instructions that are carried out by your computer's hardware. This will be a shorter video as this is part 2 of our Chapter 4 lecture, so if you haven't already watched part 1 on hardware, do that now. Before we get into software, we should first talk about how we acquire it and where it comes from. When it comes to software, we can either create the software ourselves or use off-the-shelf software someone else has already made. Developing software ourselves requires significant investment in time and resources, and introduces risk of the project being a failure or delayed. This is why businesses tend to use off-the-shelf software when they're able to. You might think of purchasing off-the-shelf software as buying the software, but in reality, you're only just purchasing a license to use that software. This license dictates what you can do with it and how you can use it. And it often makes it clear that you don't actually own the software, and you're merely just granted the rights to use it in a limited capacity. We tend to see two main varieties in terms of software licensing: proprietary closed source software and free open source software. But before we get into that, let's first explain what I mean by source when I say open or closed source. By source, we're referring to source code. Source code is written in a programming language, such as Python, Java, C, or PHP, to give instructions to the computer. The example we can see on screen right now is an example of some Python code. I don't expect you to understand this, just to understand that source code are the instructions we give to a computer that a human writes. This source code is great for a trained programmer to understand, but a computer only thinks in zeros and ones, as we saw in our hardware lecture. As such, this source code has to be converted to a machine-readable format that's understood by the computer. We call this machine code or machine language. This process of going from source code to machine code is called compiling, and it's normally not reversible. This means that companies can choose to distribute their software as source code, like we see on the screen right now, or machine code. The key difference here is that source code is easily modifiable, while machine code is not. Bringing this back to software licensing, we commonly see software distributed under one of two types of licenses: proprietary or open source. Proprietary licenses are typically closed source. This means that they only give you the machine code, and the terms of the license are such that you are not allowed to modify the program or redistribute it to others. Software distributed under proprietary licenses are typically purchased for a one-time fee or a subscription-based fee with, for example, a monthly fee. Open source licenses are different in that they provide the source code and permit users to fully modify or customize that software as they see fit. They also typically grant rights to redistribute the software so long as this is done under the same open source license. You can use and modify the software and then give it to someone else, but if you do so, you have to use the same license and keep it open source. Open source software also tends to be free, but this is not always the case. The big difference between these two is the level of support you'll get with them. Proprietary software often comes with a support contract that allows you to call up the company and ask them for help, or help with integrating the software into your information system. Open source software, on the other hand, rarely has support contracts, and the only kind of support you're going to expect is going to come from the documentation provided with the software, as well as from other people in the open source community, just sort of volunteering to help you on their own terms. Some examples of closed source software are Microsoft Word, Microsoft Access, Photoshop, the Windows operating system, and even free software that's closed source, like Adobe Reader. So closed source software can be free, it just doesn't provide the source code. Examples of open source software include the Linux operating system, the Firefox web browser, and the Dia diagram editor, which we use in this course. Also, many commonly used server applications, like MySQL and Apache, are open source. So which one of these should you use for your business? Well, as always, that depends on your business's goals and objectives. If a support contract and software just working is important for you, and cost is not of any kind of concern, proprietary software might be the best idea. If you need the ability to customize the software, or have cost constraints, open source software might be the best option for you. One thing I should point out, however, is that while open source software is commonly free, there are still costs associated with its use and modification. For example, you need to hire developers to modify the source code, or hire more IT personnel to support it, as you won't have a support contract with the company that made the software. One common concern we tend to hear about open source software is that it will be less secure, as anyone can read the source code. This, however, is definitely not the case. Properly designed software should be secure regardless of if you can read the source code or not. Furthermore, open source software can frequently be more secure, as anyone can audit it and inspect the code. Whereas with closed source software, you're putting all your trust in one company to make this software correctly. There's no easy way to check it yourself. Even if the company you're buying it from is not malicious and is honest, or trying to hide anything in their source code, they still could be taking shortcuts in development regards to security that you'd have no way of knowing about until after the fact. Another consideration is that open source software often comes with a share-alike or viral license. This means that if you're using open source software and invest significant time and resource into improving it or modifying it, you're forced to share your changes and improvements publicly. This can limit any competitive advantage you gain from this investment, as a rival company could simply use your software without their own investment. On the other hand, closed source software licenses often come with restrictions like how many computers you can install it on, what you can use it for, or have different rates for commercial and non-commercial use. In the end, your company will likely employ a mixture of both closed source and open source software. Now that we've covered the different types of licenses, let's talk about the types of applications and where they come from. One-of-a-kind applications are software developed for a specific and unique need an organization may have. Common example is the company's website, or an internal HR or inventory management system. This type of software is typically created by the organization itself for its own use, or the organization contracts a third party to make the software solely for that organization. In such a case, the organization typically retains full rights to the software. Horizontal market applications provide capabilities that are common and desired across all organizations and individuals in an industry. For example, word processors, spreadsheets, and presentation software. Vertical applications serve the needs of a very specific or niche industry. This could be things like appointment scheduling software for doctors, learning management systems for educational use, or developmental tools for programmers. Here we see a diagram from our text that I think does a good job of summarizing these software types versus where they come from. We can see that horizontal applications tend to be off the shelf, either open or closed source software obtained from a third-party vendor, which works right out of the box without any kind of customization necessarily needed for us. Vertical applications can either be off-the-shelf software that works out of the box, or off-the-shelf software that is customized for the needs of a business first. For example, a company might use open source software, which they then modify for their needs. One-of-a-kind software applications are mostly custom developed by the organization using them, or they hire a third party to work on behalf of the organization to create them. Let's now move on to categories of computer software and how we can classify different software packages. So the first way we can categorize software is by operating system or application program, or sometimes it's called application software. Operating systems, or OS for short, run your computer and control the hardware. They are programs that control the computer's resources, including tasks such as reading and writing, allocating and managing main memory, controlling the execution of programs, error handling, displaying the GUI, that's the graphical user interface, and handling input and output from devices like keyboards, monitors, mice, printers, scanners, and so on. Examples of operating systems would include things like Windows, macOS, and Linux. Application programs are programs that are run by or through an operating system. They provide some services or functionality outside of simply managing resources. There are many examples in this category. For example, we could take the software we're using in this course: Microsoft Word, Access, Excel, and the DIA diagram editor, and much more. So also to note, this category can also include software that's offered through a web browser. So in some cases, you can use Excel and Word through your web browser. But anyway, let's now take a closer look at operating systems. Operating systems can be further subdivided into desktop, or non-mobile clients, as our textbook calls them, mobile clients, those would be for phones and tablets, and server operating systems. So just like we saw when we were looking at the difference between client and server hardware, there's also quite a few differences between client and server software. In fact, you could say these are the larger difference between a desktop and a server is the software as opposed to the hardware. Looking now at desktop operating systems, These would be the operating systems used on home computers, such as desktops, laptops, and Apple computers. We can see that the most popular operating system for the home market would be Microsoft Windows, followed closely by Mac OS. That'd be what's run on Apple computers. Data I'm showing right now comes from tracking web traffic to determine OS use. Windows is known for providing a simple graphical interface and having wide compatibility in terms of application programs and software. Windows is also the most popular desktop operating system used in a business setting. And this is often included with other supporting software from Microsoft, including things like Word, Excel, Access Outlook, and support services. But Windows is not the only desktop operating system. Apple computers, for example, mostly run Mac OS. In some cases, it's possible to install Windows on them, but most Apple users stick with Mac OS, and that's shown right here in this screenshot. In the past, Mac OS was targeted largely at artists, video editors, and others in the art community, but it's since found a much more widespread adaptation in the home market. One of the big draws of Mac OS is its simple integration with iPhone and the easy-to-use interface. The downside, as some of you have learned with this course, is that it's not always fully compatible with all software we use in business, such as Microsoft Access. Next up is Unix and Linux. These are open source operating systems that used to be targeted mostly at programmers, enthusiasts, and for use in server applications. However, there's been more of a push recently for them to be used as desktop clients, and a significant effort has been put into improving their usability for less technical users. Ubuntu Desktop, for example, is a flavor or distribution of Linux targeted at desktop users that aims to keep things as simple as Windows in terms of the graphical user interface. Big advantage of these operating systems is that they use a package manager, which is a kind of like an app store, but where everything's free and open source. If you need a word processor, just tell the package manager to install one for you, and it goes out and downloads and installs it without even having to open a web browser. A big limitation for these operating systems is they're not compatible with software designed for Windows or Mac OS in most cases. And you primarily have to use free and open source software that's available in your package manager. Unlike Windows and Mac OS, Linux tends to come in a variety of flavors, or distributions as we call them, that are created by different organizations or foundations. These all use the same basic architecture and core programs, but have minor differences in the GUI, prepackaged programs, the installer, and the package managers. I already mentioned Ubuntu Desktop, which we see a screenshot of now, but there are also popular distributions such as Fedora, Arch, SUSE, Gentoo, CentOS, Red Hat, and many, many more. There are tons of them. And they all tend to target a different niche use or special case. For example, Ubuntu Desktop tries to target non-technical users with a very simple-to-use GUI. Unix is less used than Linux nowadays, but they share a close history and architecture. There's no longer a pure Unix anymore. Instead, like with the Linux, we see different implementations and distributions like FreeBSD, OpenBSD, NetBSD, and others. In fact, macOS is actually a descendant of Unix and shares much of the same architecture under the hood. In some cases, you can even run Unix programs on macOS. Moving on now to mobile operating systems. These would be the operating systems that power devices like smartphones, tablets, and some more specialized devices like smart TVs. Currently, the most popular of these is Android, followed closely by iOS. iOS being the operating system used by the iPhone. The first one to discuss is Symbian and BlackBerry OS. These are both discontinued now, but played an important role in the history of smartphones. BlackBerry OS screenshot is shown here on the left, and the Symbian on the right. Symbian was at one time the most popular mobile OS, with around 67% market share, but quickly lost this lead after it was displaced by iPhone and Android. BlackBerry OS was only used for BlackBerry phones, created by Research in Motion, or also called RIM, here in Canada. They targeted business use, but RIM has started transitioning away from BlackBerry OS in favor of a customized Android operating system. Next up is iOS. This is the operating system created by Apple computers for their iPhone and iPad. iOS is a closed-source proprietary software that's limited to only running on devices made by Apple. This has the advantage of being fairly easy to develop for, as there's a limited number of hardware possibilities and screen sizes to account for. The downside is that you're now locked into the Apple ecosystem, and you can only use Apple's App Store and Apple's hardware. Android is a Linux-based mobile operating system developed by Google. It's the current market leader and the main alternative to iOS. Android is offered as an open-source operating system that companies are free to use and modify for their phones. This open-source nature has led Android to be the most popular mobile operating system, as any cell phone manufacturer can choose to use it rather than spending the time and effort to develop their own operating system. Samsung, a popular phone manufacturer, for example, uses Android on their smartphone lines rather than developing their own operating system. Android has the advantage of being more open and less restrictive. While Google does offer an app store called the Play Store, users are not forced or locked into using it like they are in iOS. They can, in most cases, install applications from any source, so long as they have that enabled on their phone. The last mobile OS to mention is Windows 10 Mobile. This is a version of Microsoft's Windows OS targeted at smartphones and tablets. Fortunately, it's failed to achieve any significant degree of market share and is now being discontinued by Microsoft. This brings up another important point to consider when selecting software for your business. One question you need to ask is this software still going to be supported in a year or two? Even large corporations like Microsoft have products that end up failing to gain acceptance. And if you invest heavily in using this software for your business, you'd be in trouble if it were suddenly discontinued. Considering the market share of an existing offering and being skeptical of new entrants is key to making this choice well for your business. Next up are server operating systems. These might be a bit different than what you're used to using, because instead of aiming for usability or easy-to-use interfaces, server OSs are optimized for performance. Most are customizable and allow any unneeded components to be removed. For example, in many cases they have no GUI at all, and only offer a text-based terminal that the user has to type commands into. Shown here is the terminal for Ubuntu Server, and this is a Linux-based operating system. I should clarify that users in this case would be the server administrators that maintain the server, as opposed to your traditional end user. They also rarely are sitting at the server and typing into a keyboard, but rather they're connecting to the server remotely. Currently, Linux and Unix OSs are dominant in the server market, with about 80% of the market share. This is largely due to their customizability, allowing for any unneeded components to be removed or customized for your needs. Also, much of the server application software we see is Linux-based, and may not have alternatives in the Windows ecosystem. Microsoft also makes a Windows-based server operating system, which is essentially a stripped-down version of Windows with added security features and optimized for server application software. Mostly only sees use when it's required to support Microsoft applications like SQL Server, Active Directory, and to support Windows desktops that are being used in a business, as well as sort of network shares and accounts for them. This finally brings us to application programs. Recall that these are the programs that run on an operating system or through a web browser to provide us with some service or perform some function. We can classify these into two different categories: native applications and web applications. Native applications are the traditional type of applications which are designed and created to be run on a particular operating system. For example, Word, Access, and Photoshop are all designed to run on an operating system. Sometimes there's versions for multiple operating systems, but the key here is that they are installed and run directly on your computer. Native applications are also sometimes called thick client applications. Web applications are programs offered through a web browser. This can be things like Google's Gmail, Facebook, or even OWL, our learning management system here at Western. There are also web application versions of programs such as Word, Excel, and PowerPoint that can be used through a browser. The advantage of web applications is that they don't need to be installed. They work on any operating system, so long as they have a compatible browser to use them with. And they normally keep your data in the cloud, such that it's available regardless of where you're using the application from. This is why we sometimes call these applications cloud applications. The downside is that if you have no internet connection, you can't use them. Also, you don't really own the software in any physical way, like if it was on a DVD or a flash drive, and once your subscription ends, you may lose access to the application, and even worse, your files. Similar to how native applications are called thick clients, web applications are called thin clients. Another type of software we should mention is firmware. This software is not installed on a hard drive or solid-state drive, but in a microcontroller's read-only memory, also called ROM. I have here an example of a programmable microcontroller, in this case an ATmega, and one or more of these would be soldered into a circuit on your device and handle simple tasks such as sending the correct IR code on a remote control, or keeping your refrigerator at the correct temperature. So additional examples of such devices that largely use firmware would be things like printers, network routers, Blu-ray players, TVs, remote controls, refrigerators, cars, and far more. These all tend to have the software installed right onto the chip, rather than on like a hard drive or something that the user can access. And speaking of which, normally the end user does not have direct interaction or even notice this firmware. Like you don't really consider the software that might be on your remote control to make the different IR codes go. And in some cases it is necessary to upgrade or update the software, but this is not normally done by the end user, but rather through IS professionals, as there is some risk if the update goes bad or something goes wrong that you'll brick the device. What we mean by brick the device is make it no longer usable because it's in a state where it can no longer be updated or used. The reason why we use the word brick is because it's essentially now a brick or a paperweight. One last topic we should mention is virtualization. This is the process by which one computer can host one or more virtual computers within it. We call the operating system of the physical computer that actually hosts another operating system the host. The host runs and controls the activity of the virtual machine, the virtual machine being the operating system that's being run virtually within the host computer. So I know this all sounds a bit confusing, so let's go take a look at this in practice. So here we have a standard Windows computer, and this is an actual Windows computer. It's a physical one that's right in front of me. And on this computer, we have some special software installed called VMware Workstation. This is called a hypervisor. It's software that essentially allows us to run virtual machines on our host computer. Once again, in this case, the host computer is running Windows. The host computer is the physical computer that's in the room with you. Now, I have a few virtual machines already installed on here, macOS and Ubuntu. So I'm going to start by running Ubuntu. What's happening right now is it's booting up a virtual machine. So everything in this window that you're going to see is a virtual computer. It's not actually existing anywhere. We're not remotely connecting to anything. This is a computer that's completely virtualized within my Windows computer. And it's even running a different operating system, Ubuntu, which is a distribution of Linux. So I'm going to log in here. And it works sort of just like a little computer in a different window on your main computer. There, we're logged in. Now we can try running something on this virtual computer. So in this case, I'm going to run Firefox. One thing you might notice is these virtualized computers, these virtual machines, tend to run a lot slower than the host operating system. So there's a lot of overhead when you're starting to run virtual machines, which means you're going to get a slower result than if you just had the operating system installed directly on your computer, for example. Let's try going to YouTube on the virtual machine. And we'll look for CS1032. And here's one of our videos. So you can see it works just like a normal Ubuntu computer. We can also have multiple virtual machines running at the same time. So on the right here, I also have macOS. And this is running the Dia diagram editor. You have the same sort of applications you'd see in any macOS computer, except it's a virtual one running on Windows. Now you might be asking, well, that's cool, but what's the use of this? Well, there is quite a few. So for example, if you're a programmer and you want to develop some software and make sure it runs on Windows, on Ubuntu or Linux and macOS, instead of having to actually go out and buy each one of those types of computers and install that operating system on each one, you could use a virtual machine to test your software before you actually try it out in production. So save yourself a little bit of time and effort there. It can also be used for security research and stuff. If you want to test an application that you're not sure if it's secure or not, you can install it on a virtual machine because these virtual machines are isolated from the host. So on this Ubuntu computer, for example, we can't access files from the host computer unless we allow that. So it's sort of completely isolated. So if we were to accidentally install a virus on here, for example, it wouldn't make it to our host Windows computer. Same thing with the macOS one. So security is another feature. And another thing is, in some cases, we use this on servers. So instead of having like a desktop like we do here with Windows, we might have a server without a desktop environment that then can spun up multiple virtual computers. So we'd have a host server that runs a bunch of virtual servers. And this is what we'll start getting into talking about when we talk about cloud computing. And the idea here is that you can sort of start up servers on demand. So a company would have like a big beefy server in their data center, and on that it might run like 6 or 7, maybe even up to 10 or 12 little virtual servers. And then they could rent those virtual servers out to other companies for their needs. And the goal there is that you've just spun them up when you need them, and you can shut them down when you don't need them. So you can sort of load balance things between different tasks. It's also a great way to sort of isolate things. So if you have one customer using one virtual machine, one customer using the other virtual machine, since those machines are isolated, they can't really interact with each other. And so you have another layer of security there. Now, another great use for this is educational use. So you at home, you might want to try downloading VMware and try running a few different operating systems. So you can just see what like Linux is like, or what a different operating system is like that you don't normally use, without any risk to it. Because installing this in the virtual machine isn't going to affect your host computer, you don't have to worry about accidentally like deleting your files or anything like you would if you're actually installing a brand new operating system on your computer. So it's also great for educational uses. One last use case is if we, for example, had a Mac computer and we couldn't run Microsoft Access, what we could do is spin up a virtual machine of Windows, for example. There's no real limit of what an operating system it can be. So you could have a Mac OS running Windows, you could have a Windows computer running Mac, whichever one you want. In this case, you can't run Access, so you on a Mac, so you might have a virtual machine on your Mac computer to run Windows, and then through that, you would run Access. So it can also be used to run programs that aren't compatible with your operating system. And when we're talking about macOS in this course, we already saw that a little bit when we talked about MyVLab. So what MyVLab does is a little bit different than this, is MyVLab's actually connecting to a remote server that's running the virtual machine. In this case, these virtual machines are running directly on my computer. So the difference is where the host is. In this case, the host is the computer in front of me. When we're using something like MyVLab, the host is a server at Western. So to quickly summarize, virtual machines allow a host computer, that's the physical computer in front of you, to run a virtual machine of another operating system, or it could even be the same operating system if you wanted, and that provides a few advantages. It's good for testing, it's good for software development, it's good for running applications that you can't run on your normal host computer. In terms of servers, we can also run these on servers, and then we can sort of virtualize different servers and offer them to different clients, or spin them up as we need them and shut them down as we don't need them. And that gets us into cloud computing. That's all I have for you in this video, and this last topic on virtualization is going to tie in heavily when we start talking about cloud computing. That's going to be covered in Chapter 6, and it's going to come up in a later lecture video. Thank you for watching, and have a great day.